What's poppin', dogs? Mr. Allen here with a couple concentric circles in this video. Now, concentric circles are just circles that share the same center. It could be 2 circles, 3, 4, whatever. It makes this kind of bullseye looking thing here, all right? And we have the radius of the smaller of the 2 concentric circles is 7. So the radius of this circle is 7 units. And there's a chord of the larger circle that lies tangent to the smaller circle, and it has a length of 48. I want to find the area of the larger circle. Well, in order to find the area of the larger circle, I'm going to need its radius, right? Pi r squared. I'm just going to jot that down. Area equals pi r squared. So we remember. Okay. So I got to get that radius. Well, how am I going to do that? Let's see here. So let's think about what a chord is. Okay, a chord is just any segment drawn, from one edge to another edge of the circle. Anywhere through that circle, a diameter is a special type of chord, right? But it's just drawn end to end. But it lies tangent to the smaller one here. So however I draw it, right, it's going to need to lie right against the smaller circle, no matter where I put it. So I can draw this in an infinite number of ways. The way I like to do these types of problems, because I've seen them before, I wrote this problem, is I either go like up here or down here, okay? I'm going to go down here for this one and try to be as horizontal as possible and make sure that I just touch that circle. I go from end to end. Whoop, boom. Lovely. Okay. So it's tangent to that circle, okay? Kind of went through a little bit, but I did all right, okay. Well, this length here is 48, it said, right? 48, okay. I like to, anytime I have a segment that's spanning more than from one point to the next, it's going a little longer, I usually use my fancy teacher brackets to do so, to say it's this full thing, not this part right here, right? So do your best to get those teacher brackets. They are tough, takes a lot of practice, but one day you'll be as good as I am. Sometimes I still screw them up. All right, now the radius is 7. I can draw this radius anywhere I want in this circle. But why draw it right here, straight down to that point of tangency? Why would I want to do that rather than any other infinite location here? Well, a radius drawn to the point of tangency is perpendicular to that tangent, meaning I have a right angle right here, and this is 7. Now, the other thing I got to figure out is my radius of the large circle, right? That's kind of the whole point. Then I can plug it into that formula. Well, I could draw, again, an infinite number of large radii for the large circle, but there's 1 or 2 locations that truly make sense. I'm going to draw it to where that chord intersects that circle, creating a right triangle. So any chance you get in a math class, see if you can pop a right triangle on that thing, and it will help you solve the problem, okay? Right triangles, if you can somehow finagle a right triangle into a diagram, whatever it may be, whether it's circle, pyramids, whatever, okay? Cones, there's triangles within those. A lot of times you're trying to put in right triangles into a diagram to solve for some missing lengths and then continue mathing your way through that problem. So I've got a right triangle, which is awesome, and I have one known length. Well, another dealio of a radius drawn to that point of tangency is if I actually were, I'm not going to, but if I were to draw this thing straight through, okay, this is essentially a part of the radius of that large circle, right? This from here to here is a radius of the large circle. Well, a radius, if it's perpendicular to a chord, it bisects that chord. If it bisects the chord, it's perpendicular to the chord, so vice versa. So what I'm saying here is that this length, and we'll go into a different color now, I'll go orange. This right here is going to be 24. It's half of that 48, okay? So a radius, when perpendicular to a chord, bisects that chord. If it bisects the chord, it's also perpendicular. So those are some different theorems, properties, and all sorts of stuff of circles that exist that you have to remember, and it's challenging, okay? Circles have a ton of information about them that's given to you that you forget about. I think the most challenging problems involve circles because there's so many properties. You think you don't have enough, but you actually do. And now I have 7, 24, 25. So 25 is my radius here. It's a 7, 24, 25 triangle. If you did not remember your Pythagorean triples, you could also do Pythagorean theorem, and you would solve for C, getting 25 for C, okay? So now my radius is 25. Let's go ahead, plug it in there. I'm going to have area equals pi times 25 squared. I think that's what, 625? So you get 625 pi units squared. Final answer for my area of the big circle, right? Find the area of the larger circle. We got it. A lot of times in these problems too, we'll say, hey, just keep it in terms of pi, right? Do the math of the other numbers, put pi at the end. That way it's a nice, neat number most of the times. It looks like almost like an integer with just pi chilling there, okay? So there we go, concentric circles, dope. They could throw this at you without a diagram whatsoever. You have to know to draw it like this, with like the bullseye situation going on. It could just be words when you get it. They might be nice and give you a diagram. I don't know, it just kind of depends on your class, but hope that helps. Have a wonderful day.